This video is to demonstrate the apparatus for the diffraction lab for Physics 1220. So we have the apparatus here. We are using our laser that we've used in previous experiments, and we have two diffraction gratings. So one of them is a known diffraction grating, which has 540 lines per millimeter, as listed in the apparatus. And then we have an unknown grading, and this one you're going to figure out what the grading spacing is. So what we want to do is use this large binder clip, and we're just going to clip it to the side of our diffraction grating so that it can be stood up vertically, like so. And we want to shine the laser so that it is perpendicular to the diffraction grating. And then I've set up a piece of paper on the wall here so that I can view my interference pattern. The procedure does say to set it up on the table. I've set it up on the floor just because that was easier for me, so feel free to use the floor or a table or whatever setup is easiest for you. And note that the opening of the laser is quite wide and you will get quite a bright beam. So I have just taped some black electrical tape over the opening and then poked a smaller hole using a pencil into the laser so that you only get a small amount of light. Make sure that when you do this, you can use paper or tape, but just make sure that you're not doing this with the laser beam on. So notice right now it is not plugged in, so I'm not risking shining the laser into my eyes. So I'm going to plug in the laser, and I want to align it to the best of my abilities so that it is perpendicular to the diffraction grating. And I want to make sure that the laser is shining onto the diffraction grating. So it can be a little bit hard to see in the video, but you can see there is a red beam in the center of the diffraction grating. And if I have a look at my piece of paper on the wall, I can now see that I have my diffraction pattern. So this bright spot in the middle is the central, or the n equals 0. And then we have our first order interference on either side. So this is the n equals 1 on either side of the central image. And the higher order diffraction patterns cannot be seen because they get dimmer as the n value goes up. And our laser is not bright enough in order to observe any of the higher n values. Now, in order to take the measurements necessary to calculate sine theta, which is necessary to then calculate the wavelength of the laser, so that's what you're trying to determine in the first part of the experiment, we want to measure the value of W, so that is from the center to the first order image. And it is actually better to measure 2W, so from n equals 1 on one side to n equals 1 on the other side. And it's up to you how you would like to make this measurement. If you've taken a piece of paper and taped it to the wall, then you can use a pen or a pencil to outline where the bright spots occur and then remove it from the wall to make your measurements. Or you can take your ruler and line it up with those bright spots and then make the measurements directly on the bright spots. So recall that when you're using the ruler typically, rulers typically have millimeter divisions, and you also want to consider any physical uncertainty. So even though I've made a small opening for my laser beam, the laser still has some width, so depending on your laser, my beam has about 1 millimeter of width. So you'll also want to consider that as part of your physical uncertainty when making that measurement. Then when you want to measure the value of L, so L is the distance from where the pattern is observed to the diffraction grating. So it's not from the pattern all the way back to the laser, which is behind the camera. So you want to make sure that you are measuring the distance from here, so from the wall or the paper or the pattern to the diffraction grating. If you're using a ruler like this, there's usually a little bit of space before the 0 line. So yeah, it's kind of hard to see here, but there's a little bit of space before the 0 line. So take that into account with your measurement. If possible, I would suggest that you use a tape measure instead. So tape measure, you can press it all the way up to the wall and then use that to measure the value of L. So from the pattern to the diffraction grating. In the second part of the experiment, you're going to take out the original grating and replace it with the unknown grating. And you're going to repeat the same measurements you did in the first part. So again, we're looking for that n equals 1 case. So notice now that the bright spots have moved from where they were earlier. That is because we have a different grating and have a different grating spacing. So our bright spots for our interference pattern are going to show up at different spots. So again, you're looking for the distance from the center to the n equals 1 case, and it is better to measure that 2W value. So from the bright spot on one side all the way to the bright spot on the other side of that central image. So again, you could make a mark on your piece of paper, or you can just take your ruler or your tape measure and line it up right with those bright spots and record your measurement directly from here. And again, you want to make sure that you're measuring that L value, so that is from the pattern to the diffraction grating. So even though you may have tried to put it back in the same spot as the previous grating, because you did move it around, it's a good idea to measure that L value again, just in case you didn't put it exactly back in the same spot. So that's actually all the data that you'll need to collect. And then from there, you can move on to the calculations where you'll be determining the grating spacing of the unknown grating.